Alright, this video is going to go over the level 4 practice for Unit 6. So as you can tell, this first section is a section of solving equations. And we're going to do something kind of different for solving these equations. We're going to start with kind of a simple one here. So we have 2 to the x equals 8. And basically the premise that we're going to go off here is that if you have the same base, your exponents are going to be equal. So we can see that we have 2 to the x. Sorry, I'm not sure what happened there. And now we want to figure out how can we write 8 as a base 2. So 2 to the what gives us 8. So maybe you already know that, maybe you don't. And you can try some different combinations on your calculators, or if you look at that sheet of paper with all of your perfect numbers on it, if you go to the leftmost column and you look at 2 and then just go right until you get to 8, and it's in the perfect cubes list, which means that 8 is 2 cubed. Now, as we can see, we both of sides of the equation have a base 2, and so if our bases are the same, our exponents are going to be the same. So our answer will be x equals 3. Let's go to a little bit harder one here. On 2, on the left side of the equation, we have 2 parts. Both of them have a base 3. If you recall, when we're multiplying two things with the same base, we add our exponents. So we're adding x, or 1x, plus 3x, which gives us 4x. And we want to rewrite 81 as base 3. So you're going to go to your list, look at the 3, go all the way across, and it's going to be in the perfect fourths column. So 3 to the 4th equals 81. So now both of them have a base 3. We're going to set our powers equal to each other. And we're going to solve for x, so we divide by 4. So x equals 1. 3 presents a different type of problem. First of all, I would put a 1 up here so we notice that that does have an exponent. And recall that when we have the same base that we're dividing, we are going to subtract our powers. So we're going to have 1 minus 6x. 625 is 5 to the 4th power. And then we're going to set our powers equal to each other and solve. So I'm going to subtract 1, and then I'm going to divide both sides by negative 6. So notice we're going to get a fraction here, and we're going to get the fraction negative 1/2. Oops, sorry. Alright, so number 4, the left side is ready for us. It's just going to stay the same. The right side is a fraction. Now remember what we said about negative exponents sending parts to the denominator? Well, if this is in the denominator, that means we're going to have a negative fraction when we bring it to the numerator. So first, this is 1 over 2 to the 5th, and we want it in the numerator, so it'd be 2 to the negative 5th power. You switch floors, you switch signs. So both of these are base 2. We're going to set our powers equal to each other and solve. So we add 1, divide by 2, and there's our answer. Alright, let's take a look at number 5. So we have 1 as an exponent down in the denominator here, and so again, when you're dividing, you are going to subtract your exponents. I encourage you to pause at any time, try these problems, and then check yourself, by the way. Alright, so we have 12x minus 1, and then 16 is 6 to the 3rd power. And then we're going to set our exponents equal to each other. And we're going to add 1. And then divide by 12. And so once again, this is going to give us a fraction, 1/3. Okay, take a look at 6, and we'll finish off this section. So when we're multiplying, we're going to add our powers. And so we have these like terms, 1x and 4x, gives us 5x. And then 15 is not a like term, so we'll just keep it separate. And then we have 4 to the negative 5 power, again, because we're looking at that as a fraction. And then we set our exponents equal to each other, add 15, and divide by 5. So we have x equals 2. That's our answer for that one. So that completes that section of it. Those are all of our equations, part of it. And let's go ahead and go to question 7. You should kind of recognize this because it's similar to what we did in lesson 2. And so we are still going to get the radical by itself and then undo the radical. Well, since it's a square root, we're going to square it. But when we square this right side, remember you can't just distribute that 2. You have to actually multiply out x plus 3 times x plus 3. So when you square that, you get x squared plus 3x plus 9 just by distributing. So we add our like terms, we get x squared plus 6x plus 9 on the right side, and then on this left side, basically your radical just cancels out. So we have x plus 59. So when you look at this, you should see, oh, now I have a quadratic. And remember when we're solving quadratics, we have to get everything to one side and have the other side equal to 0. So I always want to make my x squared positive. So I'm going to move this x in 59. And then we have x squared plus 5x. Just realized I brought this down incorrectly. This should have been a plus 9. You can see right here. And so then when I do 9 minus 59, it's negative 50. So it equals 0. And then there's lots of options for solving a quadratic. We have factoring and quadratic formula and completing the square. But the easiest way to do it is factoring if it is factorable. So let's check it. Do our two sets of parentheses. We have our x and our x. Remember, we're looking for two numbers that multiply together to give us negative 50 and add together to give us 5. So we're going to do 10 and negative 5. And then we're going to set each factor equal to 0. And solve. And so x will equal negative 10 and 5. I know it seems like we've already done a lot of work, so we should be done, but there's one last thing we have to do. On problems like this, there exist these things called extraneous solutions. And what those are is solutions that appear like they should work, but they actually don't. And so we have to plug them into the original just to see if they really work. And so when we plug negative 10 in, we'd plug it in on both sides. On the left side, we're going to get the square root of 49. And on the right side, we're going to get negative 7. And the square root of 49 is not negative 7, it's positive 7. So that means negative 10 does not work. When we plug 5 in, we're going to have the square root of 64 equals 8. That does work. So 5 is a solution. Oh. I'm sorry, I don't know why that's doing that, but all right, so let's look at number 8. Let's kind of ignore the writing that just moved there. Okay, so number 8 is going to be really similar. Our radical is isolated. We're going to square both sides. So we have 2x plus 3. And then we're going to square that right side, x plus 2 times x plus 2. Kind of do that in my head and simplify it all at once. And we get x squared plus 4x plus 4 after we add our like terms. Once again, we're going to get everything to one side. So I'm going to subtract the 2x, subtract the 3. And so I have 0 equals x squared plus 2x plus 1. And then we're going to try to factor it. And so I'm looking for two numbers that multiply to give me 1 and add to give me 2. Well, the option is just 1 and 1. And then we're going to set those equal to 0 and solve. And so x equals negative 1 on both of those. So we only have one solution. We always have to check it. So let's plug that in. So 2 times negative 1 is negative 2. So this gives us square root of 1. And this gives us 1, which does work. So negative 1 is our solution. All right, this next section is systems of equations with radicals in it. So if you recall, on systems of equations, we have three methods actually for solving them. We have graphing, substitution, and elimination. And in this particular system, it's set up perfectly to use elimination. And in fact, both of these systems will be, and any system that we ask you to do in this unit will be. So if you recall with elimination, we want to multiply one or both equations by something so that our constants on one of our variables cancel out. And so notice here we have this 3 and 3 on the y's. So if we just multiplied one of those by -1, it would give us a -3, which would cancel out. So this is what I mean. We're going to multiply the top by -1. So I'm going to multiply everything by -1. And then I'm just going to go ahead and copy the bottom equation down. And then once we've made it to where the coefficients on one of our variables is opposite, we're going to add the two equations together. So -4 plus -2 is -6, root x. -3 plus 3 is 0, so that's going to cancel. And -17 plus 5 is -12. So we're trying to get the radical by itself. So we're going to divide both sides by -6. So we have root x equals 2. And then we're trying to solve for x. We're going to undo that square root by squaring both sides. So we have x equals 4. So now once we get one of the variables, we're going to plug it into one of our equations to get the other variable. So we take this 4, I'm just going to plug it into the bottom one here. Now this, -2 root 4 is 2 times -2, so that little piece equals -4. And I'm still trying to solve for that radical, so I'm going to add 4 to both sides. So then I'm going to divide both sides by 3. And then to undo that radical, I'm going to square both sides. And so I end up with y equals 9. So if you remember back from Algebra 1, when we're solving a system of equations, we are looking at the point where two different types of graphs intersect. And so these two graphs are intersecting at 4, 9. All right, let's go ahead and look at 10. All right, so this one is not set up quite as nicely, but if we look, all right, so anyway, this equation is not set, or the system of equations is not set up quite as nicely. So what we're going to do is we're going to look at our coefficients on x, and we have 2 and we have -1. And so in order to make those cancel out, I can multiply this top equation by 2. That's going to give me a -2 on the root x, which will cancel with my +2 on the bottom. When you do that, you have to multiply everything by 2. Keep that in mind here. Just going to bring that bottom down. And we're going to add those together. So -2 plus 2, those cancel out. 4 plus -5, it's going to give us -1 root y. And 18 and -23 is going to give us -5. So I'm going to divide both sides by -1. That gives me root y equals 5. And I square both sides to get rid of that radical. So y equals 25. So I'm going to take that 25 and plug it into one of my original equations. I'm just going to plug it into the top over here. This little piece is like 2 times 5, so it's going to be 10. So then I'm going to subtract 10 from both sides. Divide by -1. And then I'm trying to undo that radical, so I'm just going to square both sides. So I get x equals 1. So my equation would be 125. Or I'm sorry, my solution to the system of equations would be 1, 25. All right. So now let's go ahead and look at this last section. All right, so this is going to be similar to our first section in a lot of ways. So you've done this before with properties of exponents. We're going to try to simplify 64 over 27 if we can, and we can't. So we're just going to leave those the same. And then I notice that I have an exponent of 1 here on my x's, and I have x to the 7th over x to the 1. So I'm going to subtract my powers. I get x to the 6th. And then there's no more y's and no more z's, so those are just going to stay the same. Now, raising something to the 1/3 power is the same as taking the cube root. So 64 to the 1/3 power is the same as the cube root of 64, which is 4. Then I'm going to distribute this to everything else as well. 27 to the 1/3 power is 3. And then everything else, I'm just going to multiply my exponents. So 6, x to the 6th to the 1/3 power is like multiplying 6 times 1/3, so 2. My y, I'm going to do 8 times 1/3, so 8 over 3. And z, 9 times 1/3 is 3. And then that's going to be my final answer there. So all my variables are combined, and I don't have any negative exponents. Number 12 is going to be really similar. So I'm going to attempt to simplify as much as I can. I can't do much here, but I can simplify my x's. (49 to the 1/2 power is 7. I'm going to multiply 2 times 1/2 for my x, gives me a power of 1. Z, I'm going to do 7 times 1/2, so 7 halves. 25 to the 1/2 power is 5. And then on my y, I'm going to do 8 times 1/2, which is 4. No negative exponents. I don't have anything with the same base. That tells me I am done. First thing I notice about 13 when I go to do this is that in the numerator, 81 is the base of both of those parts, which tells me that I can add my exponents. So I'm going to do that. I get 14/15. I'm going to leave the bottom the same. Then I kind of think back to what I was doing in the beginning of this practice, this 4.0 practice, and I remember that I rewrote 81 as 3 to the 4th. So I'm going to do that here as well. Oh, I put an extra 1 in there. And notice now I have the same base on top and bottom, so that was probably a good move. So then when I have a power of power like this, I'm going to multiply my powers, which that's going to give me 56 over 15. Now I think, okay, I have the same base on top and bottom. I can subtract my powers, which gives me a power of 209 over 60. Remember, you can use your calculator to do that subtraction if you wish. And this last problem is going to be really similar. So the first thing I notice is that my top two things have the same base. So I can add my powers. And then I look on that little paper and see if I can rewrite 256 as 4 to some power, which I can. It's 4 to the 4th power. And then I multiply those powers up here, so I have 4 to the 28/9 over 4 to the 2/5. I'm going to subtract 28/9 minus 2/5, which is going to give me 122 over 45. They're not negative exponents, so that tells me I'm done.